Welcome to this edition of Dwyer Tech and Specs. In this video, I will cover control valve sizing. Control valves are used to change process conditions such as flow, temperature, level, and pH. A complete control system would include a sensor, controller, positioner, or current to pressure transducer, and the control valve. Globe valves, such as Dwyer's high flow series, are a very common type of control valve. In the example shown, a high flow valve is controlling temperature by varying the amount of steam or cold water added to the process. It is essential to correctly size a control valve for the application, or the process will not work effectively or efficiently. A control valve is always selected according to the application flow requirement, not the line size that it is installed in. All control valves have a rated flow capacity expressed as the CV rating. CV is the valve flow coefficient and is the number of US gallons per minute of 60° Fahrenheit water that will pass through a fully open valve with a 1 psi pressure drop. For example, a high flow valve with a CV rating of 10.75 will pass 10.75 gallons per minute of water with a pressure drop of 1 psi across the valve. To select the proper valve for the application, it is necessary to calculate the needed flow capacity, or CV. The necessary CV will be dependent upon the pressure drop across the valve. The greater the pressure drop taken across the valve, the greater the flow through the valve. How much pressure drop should be taken depends on the application needs and the pressure available. The required application CV is calculated with different formulas according to the medium type, liquid, gas, or steam. For gas, use the equation shown, with CV dependent upon upstream pressure, downstream pressure, pressure drop taken, volumetric flow rate needed, temperature, and specific gravity. If taking greater than 50% of the upstream pressure for pressure drop, use the shown simplified equation. Here's an example calculation for a gas application. For steam, use the equation shown, with CV dependent upon upstream pressure, downstream pressure, pressure drop taken, and mass flow rate needed. If taking greater than 50% of the upstream pressure for pressure drop, use the shown simplified equation. Here's an example calculation for a steam application. For liquid service, the pressure drop must not exceed 50% of the upstream pressure. Use the equation shown with CV dependent upon upstream pressure, downstream pressure, pressure drop taken, volumetric flow rate needed, and specific gravity. Here's an example calculation for a liquid application. Once the required CV is determined, selection of the proper size control valve can be obtained by comparing the calculated application required CV to the CV values for the high flow valves. To size properly, it is best to increase the required CV by 10 to 15% to account for different operating conditions. Also, the minimum required controllable flow should fall within the rangeability of the valve. The rangeability of the high flow valves is 50:1. For example, if a high flow valve was chosen with a CV of 10.75, then the minimum controllable CV would be 10.75 divided by 50, or 0.215. The CV values for the high flow valves are shown on the Dwyer catalog pages and instruction manuals on our website. Shown are the CV values for the high flow valves with full ports and linear characteristics. Don't forget to check back for our next edition of Dwyer Tech and Specs, covering control valve operation, direct and reverse acting, and fail open and fail closed. Dwyer Instruments, right choice, right price, right now.